Hi, everyone. I am pleased to welcome you to episode 600 of the People Behind the Science podcast. Listeners, today marks exactly 7 years since we launched our show, and we wanted to take a moment to thank everyone who has been part of this great adventure to share the stories of scientists with the world. So, listeners, thank you for being there with us along the way. And today we are rebroadcasting our interview with Dr. Jess Adkins, originally published on December 24th of 2014. Jess's research combines oceanography, geochemistry, and environmental science to answer important questions about past climates and climate change. He has been involved in marine expeditions around the world to study deep-sea corals, sediments, and the surrounding waters. And in our conversation, Jess shares some great stories and insights. So I hope you're ready to dive into this episode of People Behind the Science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to another episode of People Behind the Science. I am excited to be here today with Dr. Jess Adkins. So welcome to the show, Jess. How's everything going today?
It's going great. I managed to get my daughter off to camp on time in the morning, which is a victory every day here in the summer.
Gotcha. Well, definitely a victory to celebrate in the morning. I like that. Well, listeners, I am delighted to introduce you to Jess. Jess is a professor of geochemistry at California Institute of Technology. He received his PhD in Chemical Oceanography from MIT and the Woods Hole Oceanographic Institution. He then completed postdoctoral fellowships at the Lamont-Doherty Earth Observatory and at the University of Minnesota before joining the faculty there at Caltech. Now, Jess has received many awards and honors during his career, including the Houtermans Medal from the European Association of Geochemistry, the Ruth and Paul Fye Best Paper Award from MIT and the Woods Hole Oceanographic Institution, and the Organic Geochemical Division of the Geochemical Society's Best Paper Award. Now, Jess is here with us today to tell us all about his journey through life and science. So today, Jess, we are thrilled to get to know you, both as a scientist, but also as a person. So can you take a few minutes to tell us what you like to do when you're not doing science?
Well, you have to be careful, right? What academics like doing, but talking about themselves, right?
Right.
It could be way more than a few minutes. But let's see. When I am not doing science, though it sort of feels like I'm thinking about it all the time, I really enjoy coaching my kids' soccer teams. My 10-year-old son and 8-year-old daughter both play soccer, and I find that a lot of fun to be out there in the field with them and their friends. I like going hiking a lot in the mountains here. Who knew there were mountains in Los Angeles, actually? That was a big surprise to me when I moved out here. And I just took a trip back to the Adirondacks with some dear friends from my summer camp days to do an epic climb that we had been trying to do for a while. So I enjoy that a lot. Yeah, cooking with my wife, barbecuing on the weekends, trying to perfect a smoked rib recipe, these sorts of things, I think.
Fantastic. Well, it sounds like you've got a wide variety of interests, Jess. I like this. Running around in the soccer field with the kids. This epic climb in the Adirondacks sounds fantastic. How'd it go?
It went okay. I almost finished.
Yeah.
They didn't have to air vac me out or anything like that. No emergency crews were called in, so I'll consider that a victory.
That is a success, absolutely.
Yeah.
Well, sounds wonderful. Great to get a little flavor about what you do when you're not at work. Now I'm going to ask you about your scientific side, though, Jess. Can you tell us how you describe what you do to someone who's not in science?
I'm an oceanographer, and I work on the history of the Earth's climate. And that usually can branch off in a couple different directions. Most people immediately think when I say I'm an oceanographer that I swim with the dolphins or dive on coral reefs. That gets even more complicated when I tell people I work on corals, but not actually the ones that they've been snorkeling on. I don't really do any of those things. I like dolphins just as much as the next person, but I probably know as much about them as you do. I tend to work on the deep ocean, the sort of deep, dark, mysterious interior of the ocean, because that's the spot that has a lot to do with the long-term shifts in climate, where we've seen glaciers come and go, ice piled up on top of Canada and then going away, sea level changing by 120 meters over the cycles of glaciation. I do that with an aim towards trying to understand the natural laws, the inner workings of the levers and cogs of the climate system, because I think we're confronted with a grand challenge right now of what to do with the experiment we're running on our own climate, increasing the CO2 in the atmosphere at sort of unprecedented rates. And that makes for a very exciting research topic. I branched out recently into a variety of other things. Maybe we'll talk some about that in the interview, thinking about even deeper time in the Earth billions of years ago. But in short, I'm an oceanographer who grew up as a chemist and kind of a mathematician, and it's been very fun to have to work in oceanography just because you have to kind of know it all at once. You can't just know the chemistry of the ocean and think you're going to understand the whole system, because the biology and the physics and the geology interact so intimately with studying the chemistry of the ocean that you really get to kind of work on it all at once. And that makes it very exciting to be an oceanographer.
Certainly a lot of variety in the depth of knowledge you have to have. I like that. Well, I like that you have to immediately back up your description. I'm an oceanographer, but I don't get to swim with dolphins. I don't get to...
Right. I don't know anything about killer whales, right?
I can't help you there, yeah. So do you do any deep sea diving or roving, or are you mostly operating from the ship in the lab?
We've had the great opportunity to dive down to the bottom of the ocean, both using robots tethered to the boat called remotely operated vehicles, and autonomous submarines, which are just these fantastic robots that I am amazed by every day, that you throw over the side of the ship, they swim away, in 24 hours they come back full of data and pictures. And we've been especially lucky to be able to dive in human-occupied submarines, especially the one run by the Woods Hole Oceanographic Institution called Alvin. And members of my group have been down 3,600 meters in the ocean. That's a couple miles down, looking for corals on the bottom of the ocean, which has been very, very exciting.
Well, fantastic. It is great to hear a little bit more about what you do at work, what you do in the lab. So with all this amazing work that you do in a day, as well as trying to balance things like your family, hiking, things you like to do outside of the lab, I'm always curious to hear when I talk to scientists, what motivates them? How do you get everything done in a day? So can you share with us one of your own favorite motivational quotes or sayings that really inspires you?
Yeah, I don't know that I really have any motivational quotes. I have Marguerite's picture, Ceci n'est pas un pipe, on my wall every day. So I see that and reminded of sort of the absurdity of life and what we're up to. My favorite painting, I have a reproduction of it on the wall, that's Las Meninas by Velasquez, and I find that very inspirational for thinking about how we represent what we think we know on a canvas. But maybe probably the best motivational quote that keeps us going around here is that when life gives you lemons, you got to make lemonade. And it's kind of trite and old-fashioned, but it really is kind of what it's like day to day, is that things mostly don't work. And the key is to try and sort of keep your chin up about that and at least patch them together and get them to work, because somewhere in the not working there is a new answer.
Certainly. Well, I like that approach to life, taking what you have and making the best of it. And interesting to hear, it sounds like you're a bit of an art buff. Is this something that you had an interest in art throughout your life?
That was sort of imposed upon me, I think, mostly from my mom and from her mom. I grew up outside of New York, and so had access to all of the fantastic museums and culture institutions there, and was dragged as a kid, dressed up in shirts that felt uncomfortable, to the various museums like the Met and the Cloisters and the Frick. And somehow that kind of rubbed off, even though most of my early memories of it involved just wanting to go get a hot dog and some ice cream.
Right.
Yeah.
Well, that is wonderful. Very interesting. I always like to hear about, what are some of scientists' interests and passions outside of the world of science? So Can you take us back now and tell us a little bit more about your career, and maybe in particular, some of the people who really had an influence on you, some of these people who you considered role models?
Yeah, so I think like many scientists have been blessed with fantastic teachers along the way and guides along the way. And maybe most importantly, going all the way back to high school, I had a great chemistry teacher, Mrs. Zook. Not many people can say that, I think, that they had a great high school chemistry teacher, but she made this subject come alive, especially in the lab. And it's something that I still love to this day, going into the chemistry lab and mixing things up and making things and making measurements. I had two fantastic math teachers, Steve Frauenthal and Ed Barlow. Mr. Barlow is probably the person I was most scared of in my entire life.
Really?
But he taught me calculus in high school. We didn't have a textbook. He taught it from the theory of limits, and we derived everything, not knowing that that's what we were doing. It was really one of the most fantastic learning experiences. And as I look back, I remember interviewing and going to colleges to try to go to campuses to figure out where I might like to go to college, and went into the bookstore and realized that there were calculus textbooks. I didn't know there were such things, and opened up the front cover And there were the answers to all of the term paper questions that we'd been handed out. He taught class as if you were sort of taking a tutorship at Cambridge University or something. And I was blown away because I realized at that moment that everybody else was forced to memorize these things that were listed on the inside cover of the calculus textbook. And I just knew them forever because I had had to derive them. And that really has stuck with me ever since. That was in high school. I was very lucky about that. I had a great mentor and chemistry professor in college, John Chizik, who I still tell stories about in class today. John was about 6'6", 6'8", something like that. And he was ambidextrous, and he could twirl the chalk in both his left and right hands, kind of like a baton, right?
Yeah.
And he could wink both eyes. And so he would stand there to see if you were getting a point. He would turn around and be twirling two pieces of chalk, winking both eyes. And it was sort of a kaleidoscope that if you weren't careful, you could get seasick just sitting in class watching him. But he clearly loved what he was doing, and that was sort of infectious and fun. My advisor in graduate school to this day, I still think is one of the greatest scientists I've ever had the chance to work with. I think a lot of us think about that way about our advisors. It's Ed Boyle at MIT. And I just in a small way tried to pursue my curiosity as much as I think he has done and is continuing to do.
Have you taken little bits and pieces of the maybe teaching styles or quirks from each of these professors? Are you there in the front of the classroom twirling your chalk, winking, and not using a textbook?
So I am not ambidextrous, and I will trip over myself in the front of the class more than I would be able to twirl everything around. But definitely Chizik with little quotes, like sometimes he'll turn and he'll say, now that was a word to the wise or a cudgel to the obtuse. And you sit there and think for a second, like, oh, man.
Where did this come from?
Yeah, exactly.
I like that.
That propensity to get off topic and tell stories, I've definitely taken from him. I try not to scare the students as much as Mr. Barlow scared me.
Yeah. Well, that is great to hear about some of these people who shaped your career, and really interesting to hear that there were a lot of influential people way back in high school who really had an impact on you and left a lasting imprint there. I think that's wonderful. Yeah,
no, it's so important, the teaching that we get in elementary and high school years. And for some reason, we've flipped the importance of those people in our society. I think a lot of us feel this way, and yet they're kind of low on the totem pole in terms of salary and respect and these things. And it's crazy.
It is very interesting to hear about these role models that you've had and get a little flavor of your journey as a scientist. And I'm curious to hear, Jess, where it all began. Can you tell us what got you excited about science and maybe chemistry to begin with? Where did this interest start in your life? And maybe hit some of these key moments along the way that really got you to where you are today.
Yeah, I mean, this is one of the things we all love to talk about, right, is our path. And I think the key here is that luck just plays a huge role in how you end up in any particular spot. You know, luck isn't the only thing. It's kind of what you do with it as well. But for sure, my story is like that. I went to college thinking I was going to be a math major, mostly due to Mr. Barlow and Steve Frauenthal. But the teaching in chemistry at Haverford was so good, and the lab part was so interesting that I got kind of captured by the chemistry department instead. And when I finished college, I was kind of done with school. I had no real interest in signing up for graduate school at that point. And
you're not alone there, yeah.
Yeah. And I didn't really want to immediately go get a job in chemistry because those jobs kind of looked like going and working for DuPont. And I had a sense that going to graduate school in chemistry wasn't going to be the thing for me because I had grown up hiking in the Adirondacks and loved being outdoors. But I didn't really know that it was possible to link up the outdoors and chemistry. And in the last moment, I was planning on moving to Boulder, Colorado to sling food and lobby NCAR for a job because it was the only institution I knew about working on at the time was acid rain was the big environmental topic. And that was the only thing I knew about that was chemistry and outside. And so I thought, well, I'll try that. And I got a letter from a Haverford alum out at UC Santa Barbara, a guy named David Lee, wondering if I wanted to be a lab technician there. And he had this great line in a letter that said, if you like the mountains and the ocean, I can't imagine a nicer place to be. And I thought both of those
I do like those things, yeah.
And the thing that he didn't mention that I did know about UC Santa Barbara was that they were the reigning national champions in ultimate Frisbee.
Wow.
And I liked playing ultimate Frisbee, and I thought this would be a great chance to see if I could play with the big boys kind of thing. And so I took this job in Santa Barbara to live there and play ultimate Frisbee. And it happened to be a job in chemical oceanography, being a lab technician in this field of working on the past climate through the chemistry of the oceans. And that's where I found this field and started falling in love with it and worked for 2 years there and then decided I did want to go back to graduate school and actually went to be with Ed Boyle at MIT, who had been David Lee's advisor, the guy I was working for in Santa Barbara. And so I just sort of became part of this lineage through total dumb luck and liking ultimate Frisbee.
Well, you cannot, discount your love of ultimate Frisbee and the places it can take you in life. So
that's right.
So how was it playing ultimate Frisbee out there in Santa Barbara?
It was great. They're very good. And I was barely keeping up. I had the distinction of helping to break the chain. We had been national champions 4 years running, and we lost in the semifinals my year. Our arch rivals, UC Santa Cruz, won that. It was a very bitter time in my life.
Very interesting. Well, these dark times are just part of the journey. So, well, it's great to hear about your journey as a scientist and how you got to where you are today. Some of these moments where things sort of fell into place. You made these connections with these people, and it just sort of blossomed into this amazing career. So can you tell us a little bit more about one of these projects that you're working on that you are thrilled to be a part of?
Well, we've just started something in the group in the last couple of years working on the isotopes of sulfur, which sounds very obscure because I guess kind of it is. But it allowed me to go to South Africa this summer, and I just got back from that trip just under a week ago, where we were looking at 2.5 billion-year-old rocks that were deposited right before the rise of oxygen in the atmosphere. You might not realize this, but the atmosphere that we have here today and that we breathe into our lungs was very, very different when Earth was first created 4.5 billion years ago. And it only started to get oxygen in the atmosphere because photosynthesis was invented. And we have opened a project through sulfur, because sulfur turns out to be quite sensitive to these sorts of changes in oxygen in the atmosphere, to try and understand how did that transition go? What is sort of the co-evolution of climate and life on much longer timescales than the glacial and interglacial cycles that I talked about earlier in your questions? And it was just amazing to be able to, A, be in South Africa, which is a fascinating country right now, and B, be walking around on a carbonate platform. So you can sort of imagine the Bahamas, except that there are no animals. The entire platform was made by bacteria, we think cyanobacteria.
Interesting.
And it is the size of Papua New Guinea, right? So that was really a very impressive visit, let alone seeing the iron mines that are there that sit on top of this platform, and how, we talk about in the U.S. how coal mining in West Virginia removes the top of a mountain, or copper mining out in the Rockies takes away a mountain. In South Africa, the iron mining takes out entire landscapes. Where it crossed the entire horizon, all you see are tailing piles. And most of that is being shipped to China right now because of its vast thirst to build the country for billions of people. It's really the global flow of goods and services written out before you, just standing next to your car, watching these huge trucks go by. That was very impressive.
Certainly, that sounds impressive. So what was it in particular about South Africa? Was it just some of these geological features that can only be found there that brought you there?
Right. So there are not very many rocks left from 2.5 billion years ago. And we like to work on calcium carbonate, or limestone, some people know this as. It's one of the ingredients for cement. In fact, some of the quarries out there are cement quarries. And we like to work on that calcium carbonate because it was made from the seawater of that ancient ocean. Just like corals make their skeleton from seawater today, and something that we work on a lot in my lab, these bacteria were making carbonate deposits out of the seawater. And so they are an archive or a record or kind of a tape recorder of what the past climate and the past ocean was like. And we try to use chemistry in the lab. We go and collect the rocks out in the field, or corals from the bottom of the ocean, bring them back to the lab, and then make precise and accurate chemical measurements, including dating them, to try and understand something about the past climate. And so South Africa is one of the only places that you have this big carbonate platform. And it turns out to be probably the best preserved one we have from right before the rise of oxygen. So it's been a very popular place to work for geologists for a long time.
Very interesting. Well, this sounds like a fascinating project, and interesting that you do get these opportunities to travel as part of it. I think that's wonderful.
Oh, yeah.
So I think so far, Jess, we've talked about a lot of the fantastic parts of your career, the amazing opportunities that you have, part of your journey to get to where you are today. We haven't yet touched on too many of these dark times. I mean, we did mention the ultimate Frisbee fail, but I think every scientist has these moments where they look back and they just cringe, or they remember these times where it was just struggle after struggle or failure after failure. And I think every scientist goes through this. It's part of the process. So can you take us back to one of these challenging times and tell us what happened and how did you get through it?
Let's see. So the list is long.
Do you want to pick your favorite?
Right. Let's see. So we try to measure in the lab metals, trace concentrations of metals in the environment. So like cadmium or lead as tracers of past processes. But of course, there's lots of cadmium and lead just in the dust around. And so one of the trials and tribulations is every day your samples can get contaminated, or while you're working in the lab, you can contaminate them. And learning those techniques was a big part of graduate school. And it was very frustrating to time and time again realize I was just measuring the blank. I wasn't actually measuring the signal of lead in snow pits from Greenland, for instance. But one of the longer term failures, like that's continued to be a failure, is one of these ones that we've decided to try to make lemonade. I started working in graduate school on these corals from the deep ocean, these deep sea corals, because people hadn't done it yet, and people didn't really realize there was such an archive down there. And once you know that there are corals on the bottom of the ocean, there are all sorts of tools you can immediately bring to it. You can try to measure the oxygen isotopes, so the ratio of O16 to O18, or the amount of strontium in the corals, and the amount of cadmium in the corals. All sorts of tracers, we call them, which are trying to measure past temperature or past circulation rate or past nutrient concentration that have been worked out in other things, in surface corals, in ocean sediments. And so the path was pretty clear of what things to try. And so I started checking them off the list. I said, let's go measure the stable isotopes of oxygen and carbon. Let's go measure strontium, calcium. And none of them worked. And I was getting further and further into a PhD on an exciting new archive that was turning out to just not record anything about the past ocean, or, from what I could tell, the current ocean. And I would make a prediction about what the next stable isotope run was supposed to look like. Like, this piece of the coral is definitely going to be the spot that records temperature at equilibrium. Mm-hmm. And then we would go and measure it, and it turned out to be the furthest from equilibrium of any piece of the coral at all. I would sort of
really,
and then people would say, you're wrong again. And it wasn't until sort of taking a step back from that I realized that all of these tracers weren't working in the same way. Like, they were all kind of correlated to each other, and they were correlated to the banding in the coral. And that has turned out to be a whole other branch of the lab. Instead of working on past climate, we've tried to understand how is it that the corals make their skeletons, and how does that process mess up the tracers that we make. It's often referred to as biomineralization, and people study this all the time when they think about how do we get teeth or how are our bones made. It's the same idea for making coral skeletons. And that's turned out to be really fun because you have to sort of be a biologist and a biochemist as well as interested in these past climate things, because the ultimate goal is to sort of unpack the black box that is the coral making its skeleton to better interpret the oceans of the past. And so that's, in a sense, been a long-term failure, and it certainly felt like it for several years while I was in graduate school, but it's turned out to be a really fun branch of the lab.
Certainly. Well, that sounds like a great adventure in graduate school. I think most scientists can relate to that moment where you make this amazing prediction that seems to make complete sense, and then you're totally wrong.
Yeah,
so
180 degrees the other way.
But you're only lucky when it happens over and over again, which it sounds like might have been your experience, right? Well, that is a fantastic, situation that you were able to work through and find perhaps some interesting tidbits, and then really almost develop this whole line of research in your laboratory to focus on that. And I've heard these coral skeleton studies likened to tree rings in terms of how things are growing and how you're analyzing them. Is this something that you draw the same comparison?
That's right. It's a good opening salvo, right, when explaining what we do, because people have heard of tree rings before,
right,
and know that somehow they're related to climate. It turns out the way that people relate tree rings to climate is something we've never been able to work out in corals. This is another one of those continual failures.
Okay.
And so people use the changing width of the tree ring, right? There's that famous Gary Larson cartoon, right, when they've just cut down this massive redwood, and it says, here in 1802 is where it survived a fire, right?
Yeah, good year, bad year, you can tell all the way.
Right, because the tree rings get thin when in bad years and thicker in good years. And one of the many things we have not been able to work out in the corals is how the width of the bands that we see in them relate to anything, or even if they're annual.
Interesting.
And so we use them like tape recorders in the same way that people use tree rings, but ultimately it's the chemical information rather than the morphology or the bandwidth information that turns out to be useful for us.
So we don't just want to talk about the challenges, the troubles. Can you tell us next, Jess, about a success story from your lab or your career, and tell us about one that's been relatively recent and meant a lot to you?
Yeah, no, we have been lucky enough to really make some headway recently on the question of how does the deep ocean relate to climate change. And when I say climate change, I mean the glaciers coming and going. So these are thousands of years sorts of changes. And I worked on kind of an idea paper about 10 years ago that pointed out that it would be possible to store potential energy in the deep ocean if instead of the deep ocean being dense because it was cold, to have it be dense because it was salty. So I'm going to back up just for a second there. So the ocean is basically a big bathtub, and it's a big bathtub with less dense water on top and more dense water down below. And if it didn't have it that way, of course, they would just mix, right? The more dense water would fall down to the bottom. And water is dense when it's cold and when it's salty. And today, the waters in the deep ocean are cold, but a little bit fresh. And we think that at the time when the glaciers were on top of Canada, the waters were cold and very salty. And so both reasons for making water dense were present then in a way that only one is present now. And that means that you could heat up the ocean and hold on to that heat without that warmth causing the whole water column to convect or have the surface waters and deep waters exchange places, until you warmed it so much that the warmth overcomes the saltiness, and then it would go off in this catastrophic event called thermobaric convection, which is just a great name to confuse people. But thermo because it's temperature, and baric because it's based on pressure.
Pressure,
yeah. And so that was a fun kind of idea paper to write. And this past spring, we published a paper in Nature where we actually measured it for the first time. Using corals that we had collected from the submarines from Alvin in the North Atlantic, we were able to show with a new thermometer invented by one of my colleagues here at Caltech that we are able to use in the corals, that there was indeed, during the time of the transition from glaciers on top of Canada to no glaciers on top of Canada, during that time, the North Atlantic had warm water underneath cold water. And the only way that can be true is if that warm water was salty. And that's been very fun because we've unpacked, from this sort of crazy idea paper, we've unpacked a totally new mechanism, a new way to think about how climate might go through these abrupt changes. And we would certainly like to collect a lot more data about it, but it has been a lot of fun to realize that there's a mechanism out there that people just have been completely ignoring. That's based on just the equation of state of seawater. I mean, it's based on very simple principles of cold and salty keep you dense and down low.
Certainly. Well, that sounds like one of those beautifully simple things that when you look back in hindsight, you're like, oh, of course, that makes perfect sense. That explains a lot. But
well, tell that to my colleagues.
Yeah. Well, that is fascinating. So you mentioned one of your colleagues had developed a special thermometer.
This is a really cool thermometer because it only feels temperature. And almost all of our other thermometers that we use the chemistry and the skeletons to try and deduce, right? So the big problem is we don't actually have a thermometer from 20,000 years ago, right? Mm-hmm. We can't sort of walk out there and go down to the bottom of the ocean and say, yes, there it is, right? You have to play these tricks that we call these tricks tracers, right? You have to use your knowledge of physical chemistry to better understand how something that is incorporated into the skeleton would feel temperature. And all of our thermometers, and we have a list of a half dozen of them or so, that feel temperature primarily, but they also feel at least one, if not six other things. And so you're never quite sure that the change that you're measuring is solely due to temperature or not due to some of these other things. And this great thermometer that John Eiler here at Caltech invented a few years ago, we know it only feels temperature. That all the other things that complicate the thermometers we've used so far are not present in this one. And so it's a much purer measure of temperature.
Interesting.
And that is just beginning to be applied in the field, and it's really exploding. We're just one use of it. Many, many other folks have tried different places where they'd like to know temperature.
Well, that sounds like a fascinating project and an exciting success making progress in this area. And really, I like you describing having this idea paper and then being able to put experiments behind it, being able to get that data to support it. I think that's fantastic.
Yeah, that was luck.
Yeah. Luck is an amazing, important feature in science. I think it comes up again and again.
Absolutely.
Well, it's great to hear about some of these success stories, some of these challenges, things that you've faced in your everyday life as a scientist. Now, I love talking to scientists in addition to, what they are doing in the lab, the research that's keeping them so busy. We like to talk about what you do in your leisure time. We mentioned some of the activities that you enjoy. And I know a lot of scientists are also avid readers. And I've gotten some amazing book recommendations from scientists. So can you tell us today about a book that you've read, Jess, and really enjoyed that you think we should check out?
Yeah, so there have been a lot of books that I've read that I've enjoyed over the years, from a kid all the way up through now, though I'm back to reading kids' books with my kids.
It's refreshing sometimes, right?
Yeah, absolutely. So a book that really made a big impression on me, and one that I still think has a lot of relevance now, is called Cadillac Desert by Mark Reisner. And it takes on what could be the world's most boring subject, or a pretty boring subject, which is the history of water rights and water flow in the United States, going from there being 13 colonies and then the federal government owning every little bit of water outside of the original 13 colonies to the current state of pumping the Colorado River into Los Angeles, right, and bringing the Owens Valley down to LA, and the huge dam projects on the Columbia River. And it's very relevant here in Los Angeles now, as we've been in the middle of a multi-year drought in California and everyone is running out of water. This book just does a fantastic job of describing how we've ended up in the situation we have. And Mark Reisner did this great job of doing it through telling stories of these sort of outsized individuals who took part in it. Mulholland is the famous one here in Los Angeles, but it really was a gripping read. And it was one of the first times that I realized, wow, we've had control over nature, in a sense. We changed the flow direction of rivers. And that aspect of man's interaction with the environment has sort of stuck with me ever since. And plus, it was just fun to read. The stories are really great.
Interesting. Well, I like how you described it as taking one of these perhaps inherently not very exciting topics, but telling it in a way that really captures some of the excitement, some of the, mystique about it, how we've been changing the environment and how we've gotten into this predicament we're in today. I think that's a really interesting sounding story. So I'll put it out there for our listeners to check out on our resources tab. And I know we talked a lot about these different opportunities you've had to do research and hinted a little bit at some of these opportunities that you've had to travel. And I know this is something that a lot of scientists really enjoy about the career, the opportunity to get out there, share your research at conferences, maybe do field work and travel, things like that. Can you think back on all these places that you've gone for science, Jess, and tell us about your absolute favorite and why it's your favorite?
So there are many favorites. Everyone isn't necessarily a favorite. I've been caving in Borneo to collect stalagmites, and it turns out I'm not a great caver. The science has been really fun, but I'm not so sure I'm going to find all sorts of new ways to try and go into caves.
Gotcha. Is it the climbing again?
Right. I'd rather be on top of the mountain than inside of it, I think. Of course, going down in Alvin was really going to, I think, still be one of the seminal experiences of my life. That was a fantastic science trip. But something that happened relatively recently was going to a conference in Israel. It's a Kaplan symposium, so money that was donated to bring in scientists from around the world every few years on a particular topic and spend 4 or 5 days together. And Israel is just a fascinating place to go visit, geopolitically, of course. It's also quite beautiful if you like deserts. And then my wife and I got a chance to actually go to Jordan and go to Petra during this trip. And that had been very high on my list. I don't know if all of your listeners know about Petra, but it is the Raiders of the Lost Ark place. So when Harrison Ford comes running out in the first movie, he comes running out of that tomb. I think it's the first movie. The tomb he's coming running out of is one of the tombs in Petra.
Did you reenact this scene?
Yes, right.
Yeah.
And yeah, you have to go there and reenact this. And it had been very high on my list as a place to visit for a long time. And often that means disappointment. And not in this case. Petra is just spectacularly beautiful and interesting. It's a little bit like taking the Canyonlands in Utah, right? And San Rafael Swell and these places with these really beautiful slot canyons in the western U.S. And you lay on top of it this mysterious civilization that dominated the spice trade for hundreds and hundreds of years and then disappeared. And the way they had dominated was by managing, just like Mark Reisner wrote about, managing the water flow in the desert. They figured out how to store water in cisterns and make it flow in aqueducts, such that this was one of the few places along the spice route where you could go and get a shower, right, as you were hiking through the desert. It's also just spectacularly beautiful, and I feel very lucky to have had a chance to go see Petra. It's full of camels and tourists and that kind of thing, but none of that really mattered. It was really a beautiful spot and sort of mysterious and spiritual spot too.
Certainly. Well, I'm sad that you seem unimpressed with the camels. I would have been pretty excited about that myself.
Kind of noisy, and a lot comes out the back end. So
Gotcha. Yeah. Well, that sounds like an amazing opportunity for travel, an amazing place to visit. And I had no idea that this was a famous Indiana Jones spot. I'm going to have to add it to my list now, too. He's sort of my hero.
Yeah.
So, no. Well, that is wonderful. I love hearing about these travel opportunities that scientists have. And you're right, you get to travel to so many places. It's kind of hard to pick a favorite when you look back. But I like that you've mentioned a few of these, caving in Borneo, being able to do some deep sea roving around in Alvin, and certainly your time spent in Israel and Jordan all sound like incredible experiences. Now, in addition to some of these great travel opportunities, I know scientists really enjoy the people that they get to work with. And I think there are some stereotypes out there about how scientists are, very serious about research, very focused. But I think scientists are people when it comes down to it. You like to have fun, and there's so many amazing, creative, and brilliant scientists out there that I've had a chance to work with. And, I think out of this, you get some quirky traditions that spring up in your different lab groups that you work in, or maybe just some funny memories that you can look back on. So can you share one of these traditions or one of these funny memories with us today, Jess?
Let's see. I think some of the traditions I shouldn't say out loud.
That's fair. You can whisper them quietly.
Yeah, but there have been several very fun things and sort of odd things that have happened as we go to the field, because it never goes as planned when you're in the field. One example was our first Alvin cruise in 2003 in the North Atlantic. And I seem to attract bad weather whenever I go to sea. It seems like low pressure systems just follow me around a little bit like Pigpen. And this was a cruise where we had to come back with samples so that we can analyze in the lab so that I could get the papers out in time to get tenure. And so the pressure was on me to sort of make this thing work as chief scientist. And we had only just figured out how to actually see the corals from the submarine on the sea floor when this very large storm system came in for a week. We were only out there for 3 weeks, and it was big enough that we just had to batten down the hatches, pull in all the submarines, batten down the hatches, and just sit there bobbing along, getting seasick. And at one point, one of the crew members was walking by where I had set up my computer and saw this little medallion of Medusa that I had brought with us. And Medusa is a very interesting character in mythology, but especially in corals. And Medusa is credited by Ovid with being the birth of coral. And that's because, so I think maybe most of your listeners know at least some part of the story, where Perseus goes and gets Pegasus and flies out to go slay one of the 3 Gorgon sisters named Medusa. Gorgons are what Gorgonians, a type of corals, are now named after for scientific naming. And the problem with slaying Medusa is that if she looks at you, you'll turn to stone. And so Perseus solves this problem by looking at her in the reflection of his shield. He, is a gory story, cuts off her head, and when he holds up her head, which was full of snakes, her hair was made of asps, when he holds up her very distinctive head, the blood that's dripping out of it lands in the ocean and fossilizes the plants, turns the plants that are there into stone. And that, in mythology, is the birth of coral.
Interesting.
And so we have, for a long time, been sort of enamored with Medusa. But as you might imagine, if you're having a bunch of bad weather and really upsetting Neptune when you're out there, one of the reasons you might be upsetting Neptune is that you're honoring Medusa, right? One of his.
This is true. You should have thought of this. Yeah.
I should have thought of this. And the crew member pointed out immediately, without knowing all of the story, it's just a really sort of aggressive and ugly medallion, right? With this dying woman's head with snakes for hair. And he said, "You can't have that out here," right? And I totally agreed with him. I said, you know what? You're right. I'll do anything to try and not upset Neptune anymore so that we can have good weather. And so we gathered the scientific and boat crew together, and I read the passages from Ovid about the birth of coral that I just talked to you about. And then we took a lock of hair from everybody at the meeting, cut off a little bit of a lock of hair, took the medallion and the hair, wrapped it in a cloth, soaked the cloth in gasoline, lit it on fire, and shot it off the back of the boat.
Oh, my gosh.
Next morning, the sun rose beautifully over a perfectly flat horizon, and we were diving by 6 a.m. It was fantastic.
I think the fire was necessary. You had to light it on fire.
Oh, yeah. No, you got to light it on fire. You got to have sort of full Viking shooting it off the back of the boat. But I think it was crucial that everybody contributed some of their hair to actually being a worthwhile sacrifice.
And I love that it just so happened that the storm broke. You had beautiful diving weather. Everything lined up perfectly.
It's not just so happened. It worked.
That's right.
I'm just as superstitious as these guys at sea now.
Well, that is an amazing story. And I think really speaks to the character of the crew, who everyone was willingly able to just throw a lock of hair and whatever, just make the storm stop. Kind of.
I think everybody was pretty seasick. And was willing to try.
Anything you said was willing to work. Yeah.
Right.
And I think a lot of people, especially in this fieldwork realm, have some incredible stories of quirky things that have happened when they're maybe out at sea or out in the field. And it's just, like you said, going back to that quote in the beginning, you have to make lemonade out of lemons. So
That's right. That's right.
Fantastic. Well, in addition to talking about some of these memories that scientists have, I love to chat about the research that you're working on, but also the research that you would love to be working on, but maybe haven't had a chance to for one reason or another. So I know these little details, things like funding and staff, technology, feasibility, constraints on research tend to get in the way sometimes of the questions that you would really love to answer. So can you tell us today, Jess, if we made all of those things not an issue, what is one research question that you are dying to know the answer to?
Well, what is the meaning of life?
I like it.
That's my philosophical roots showing through. Yeah, there are so many cool, fascinating questions, and we definitely feel like we limit ourselves sometimes because of available funding or resources, and it's a reality of the work that we do. But ultimately, I think we're limited by our own curiosity. I think there is one thing that if you gave me $15 million right now or $20 million right now, I would go out and buy a really big drill. And this drill can go underwater, and it will drill into the sediments about 150 meters down and bring the sediments back up to the surface. And it works kind of like a remotely operated vehicle. It's basically kind of like a robot on the sea floor. Mm-hmm. And what it does is it takes the derrick that you see for most ocean drilling. So I think people have seen these sorts of images, especially with the Deepwater Horizon oil spill a few years ago in the Gulf of Mexico. These boats with big derricks on them are expensive, limited resources, hard to manipulate. There's one on the Earth that is used by scientists in an international organization. The Japanese have built a second one. I suppose I should say there are two. But you might imagine that thing is oversubscribed.
Right.
For people who would like to drill sediments to get at something about the past climate. And there's been a breakthrough technology where it takes that derrick, instead of having it on the boat, it puts it on the seafloor as a little robot. And we would be able to make a lot of progress very quickly on a couple of questions. What causes sea level change would be one. What gave rise to that change in the salinity of the ocean that I was talking about earlier would be another. And a third would be to be able to go after what's living in the deep biosphere down there that we have not explored in any real sort of way. How much of life on Earth is actually below our feet and not walking around that we can see? And I think those questions would just be absolutely fascinating to go and look into. And there's been a revolutionary bit of technology just in the last few years of putting these drills on the seafloor that I would love to have one. What guy doesn't want a big drill?
Right.
That's what it comes down to.
So let's talk 150 meters. Does current technology take you down that far, or is that an extension?
150 meters into the sediment. I need to be able to go down to 4,000 meters deep in the water,
okay.
Which is why it's hard, because the pressure is so high there that everything breaks unless it all implodes, right? Unless you have very specialized equipment. Turns out those kinds of equipments have been worked out for a while, and there's a company that just took off-the-shelf things and kind of built one of these things. And it costs about $8 million and then take about another $8 million to run it for 5 years.
Interesting. Well, this sounds like a fantastic, well thought out project. You've got your questions all lined up. I think we need to make this happen.
Yeah, right. Yeah, send checks to Jess at gps.caltech.
Yeah. Listeners out there will start making a fund.
Right.
No, this sounds like a fantastic project. And I love talking about these dream questions, especially in cases like yours where some of the technology is already out there. It's just a matter, like you said, of oversubscription. You're not able to take advantage of it as much as you'd like to answer all the questions that you would like to answer the questions to. So very interesting. Now, I know when scientists are talking about these big questions, something that you like to ponder with your colleagues too, often at conferences or in your lab groups, things like that. But you also like to chat with people and get some great advice, especially when you're talking to mentors. We spoke today about some of the mentors, people who've shaped your career. Can you think back now, Jess, over all of these people you've worked with over the years, all the pieces of advice you've ever received, and share with us today what you would consider the best piece of advice?
Yeah, so I've gotten lots of good advice over the years, most of it free. So that bit about getting what you paid for, I mean, that always be true. There are several memorable ones. One definite memorable one was in my very first summer of graduate school. So kind of before even really starting, it was sort of called the 0th summer, I went and worked with a guy named Dan Rapetta at Woods Hole Oceanographic Institution in Hui. And he's an organic geochemist, and I had always been interested in the sort of more inorganic end of chemistry, metals as opposed to goo or oil or snot, right? Mm-hmm. But the organic geochemists at the time and to this day were just coming up with interesting tracer after interesting tracer. They were coming up with all sorts of amazing new ways to look at the salinity of the ocean or the temperature of the ocean or the amount of nutrients in the ocean or the state of the biome. Just really amazing tracers. And it seemed like the information was sort of limitless. And so I thought, all right, I'm going to go become one of these organic geochemists because look at all of the amazing questions you could get to go answer. And I just didn't like going into the lab. The summer was fine. Like I was living in Woods Hole, starting graduate school, all that was great. But I didn't like boiling the reagents every day. I didn't like running the chromatography columns. I didn't like the rotovap.
Not a lab coat kind of guy.
Right, yeah, all that sort of stuff. And I was talking to Dan about this towards the end of the summer about, okay, well, what project might we try to do next? And he said, Jess, you've seemed a little off, though, this summer. And I related this story to him, and he said, look, wanting to get the answer is a small piece of the problem. You've got to love coming into work every day. And if you don't, no big question is going to be enough to get you over that hurdle. You can't sort of suck up the pain for 6 years, right? In order to get to some one question at the end. It's got to be fun every day of those 6 years, or most days of those 6 years. And I think he was exactly right. And I switched back to inorganic, and it's been fun ever since. And I have lots of good colleagues do organic geochemistry. I won some best paper award in organic geochemistry recently, so I guess it's come full circle. But that was a great piece of advice that Dan gave me that, remember that it's about getting up in the morning and enjoying going into work.
Absolutely. I think that is fantastic advice. And I think, it's difficult when you're trying to decide what area you want to go into. What are these big questions you want to study? But you do have to take in mind the everyday. I mean, those days where you're going to make an amazing discovery and answer one of those questions are far outnumbered by those days that you're just going to go in and do work. So
yeah, absolutely.
Certainly important to think about the everyday, your lifestyle, what it's going to be like. Now, Jess, that is fantastic advice for our listeners. Can you share with them one last piece of advice or maybe one last piece of inspiration now coming from you personally?
Yeah, right. I think the podcast is free, right? So you get what you pay for.
Yep.
Right? But let's see. I think the coolest thing about being a scientist or being a professor and being a scientist is that you get up in the morning and it's your job to pursue your curiosity. And if you're bored, you can think about all the ways that that's the problem of the funding agencies or the political climate or whatever, but really it's your own fault. Because it's your job to go have fun in the sense of dig into some problem that you really want to go after. We are the only sector in society that I can see outside of some think tanks that are specifically told to think longer term than the quarterly business cycle. And so I think we play an important role in society that way. And it comes via just being curious and scratching that human itch. The other part that I found very rewarding and cool about the job is that after you end up learning things, you realize, wow, other folks should know about this stuff, right? Someone should make a podcast about what scientists do.
Right.
And one thing that I've done about that is I am now on the board of a very local environmental organization here in Los Angeles called Greenwish. And I encourage all of your listeners to go to greenwish.com. That's green, the color, and wish as in to wish upon a star. Because it's been a great part of the journey for me to figure out how to take all this sort of global scale, esoteric knowledge of glacial and glacial cycles and try to help it more applied to people's lives in their communities. And I think Greenwish is a fantastic organization that's trying to do just that, trying to make sure that you sort of think global but act local. And what, just like the lemonade quote, seems sort of trite, but it's one of these ones that if you actually do, your life is a lot better. And so I'll just take that chance to plug Greenwish a little bit.
Absolutely. Well, that sounds like a great endeavor. Definitely, listeners, check out greenwish.com. I'll have to check it out after we're done with our chat today. And I think that is fantastic advice to really enjoy not only the scientific aspect of it, not only answering those questions, feeding that curiosity, but also sharing this new knowledge that you've acquired, sharing it with people, making it accessible and making it available, I think is so important in the world of science as well.
Absolutely. So, we're paid by everybody's tax dollars.
That's right. We serve them.
Yes.
Well, great advice, Jess. And we have had some amazing conversations today. Can you tell our listeners now how they can reach out to learn more about you or your research?
You can certainly go to my webpage at Caltech. The easiest thing is just to Google me, Jess Adkins, and Caltech, and I think that I'm the first thing that comes up. You can also write me an email if there's something you're really interested in, though I'm notorious amongst my friends and colleagues for being bad at responding to email, but please, by all means, send me an email. It's Jess, with 2 S's, at GPS, like Global Positioning System, .caltech.edu.
Fantastic. Well, listeners with questions, be persistent. And Jess, thank you so much for joining us today and sharing a part of your story.
Thank you, Mary. It's been a lot of fun.
Absolutely. I've enjoyed our conversations as well. And thank you to our listeners out there. Join us again next time for another episode of People Behind the Science. Your voyage to the lives of today's exceptional scientists has just begun. You can find everything we talked about today, including our guests' favorite books, biographies, photos, and more, when you visit us at www.peoplebehindthescience.com. I look forward to seeing you next time on People Behind the Science.